Hi everyone, my name is Anmula Shruti. My final project is a case study in higher education. I'll be doing multi-class classification using neural networks. The goal of this project is to create a model that can predict students' performance. I have used Keras to create a multi-class classification model. In this work, we will analyze recent real-world data from two Portuguese secondary schools. The problem statement is based upon a paper published at 5th Future Business Technology Conference held at Portugal during the year 2008. Although the educational level of the Portuguese population has improved in the last decades, the statistics keep Portugal at the Europe's tail end due to its high student failure rates. In particular, lack of success in core classes of mathematics and Portuguese language is extremely serious. The present work intends to approach student achievement in secondary education. The aim is to predict student achievement and, if possible, identify the key variables that affect educational success or failure. The technologies or APIs that I have used are Keras, SCI Kitlearn, Pandas, NumPy, and Matplotlib. I have used the student performance dataset published by UCI Machine Learning Repository. The dataset has 395 rows and 33 features. I'll be using only mathematics dataset for analysis in the project. Now let us see the variables in the dataset. It consists of totally 33 features. One is sex, the other is student's age, the next is school. We are considering only two schools. Next is the student's address. Next is parents' cohabitation status, whether they are living together or they are apart. Next is mother's education, then mother's job, then father's education, father's job, whether the student's guardian is a mother, father, or another person, what is the family size, how are the family relationships. They are measured from 1 to 5. 1 means very bad, 5 is excellent, and what's the reason they chose this school, whether it is close to home, school reputation, travel time. How long does it take for the student to travel from home to school? Study time. How long the student is studying weekly. Failures. The number of past class failures. School sup. Is the student receiving any extra educational school support? Fam sup. Is student receiving any family educational support? Activities. Is student enrolled in any other extracurricular activities? Paid class. Is student attending any extra paid classes? Internet. Is student having internet access at home? Nursery. Did the student attend nursery school or no? Higher. Does the student wants to take higher education? Yes or no? Romantic. Is the student currently in a romantic relationship? Yes or no? Free time. How much free time is the student having after the school and is measured from 1 to 5, 1 being very low, 5 being very high. Go out. Is student going out with friends? It is measured from levels 1 to 5, where 1 being very low, 5 being very high. Weekend alcohol consumption. It's also measured from 1 to 5, 1 being very low and 5 being very high. Next, weekend alcohol consumption. It is measured in numeric, 1 being very low, 5 being very high. Next is DALC, which is workday alcoholic consumption, 1 being very low and 5 being very high. Next is health, the current health status. It is also measured in numeric, 1 being very bad, 5 being very good. Next is absences, the number of school absences, ranging from 0 to 93. Grades, G1 is the first period grade and it is a 20-point grading scale. G2 is the second period grade and G3 is the final period grade. Like several other countries, Portugal uses a 20-point grading scale where 0 is the lowest grade and 20 is the perfect score. During the school year, students are evaluated in 3 periods and the last evaluation corresponds to the final grade. This study will consider the data collected between 2005 to 2006 school year from two public schools. Now we have got an overview of what are all the features present in the dataset. Now let us go ahead and analyze what are the relationships present between the features. To know regarding it, I went ahead and calculated the correlation. From the results, we noticed that all the three grades G1, G2 and G3 are strongly correlated. We also noticed that mother's education and father's education are having high correlation. I have performed multi-class classification of the given data points using Keras API. As mentioned in the paper, I went ahead and classified the final grade into 5 classes named A, B, C, D and F. The goal of multi-class classification is to construct a model which, given a new dataset, will correctly predict the class to which the new point belongs to. Keras API has provided fully configurable modules that can be plugged together with as little restrictions as possible. In particular, the neural layers, cost functions, optimizers, initializing schemes, activation functions, regularization schemes are all standalone modules that you can combine together to create new models. So, as instructed in the paper, first I went ahead and converted G3 to 5 grade classes named A, B, C, D and F. Now, first I checked if there are any non-unique columns in the dataset. Next, I went ahead and checked if there are any columns which has nans. Luckily, there are no columns which have nans. Now I dropped the grade 3 column, that is the final grade column, and created 2 data frames for input and output variables. And now I splitted the data sets into train and test. Next, I performed one-hot encoding of all the categorical variables. As instructed in the paper, I am going to develop 3 models named A, B and C. Model A will consist of all the features except the final grade. Final grade is the one which we are predicting. Model B is similar to Model A but without the second period grade. Model C is similar to B but without the first period grade. For generating all the 3 models, I have followed these steps. First, I loaded the data into a pandas data frame. Then I have performed the data cleaning and splitted the dataset into train and test. Now I went ahead and performed one-hot encoding of all the object data type variables. And then I created a multi-class classification model using Keras API with 1 input layer, 2 hidden and 1 output layer. Next, I have used model.fit to train the model and saved the model to a H5 file. Next, I used the saved model to predict the student's performance. Now, I went ahead and created a model for input setup type A. That means we will be using all the variables to predict the final grade G3. I have tried various optimizers. Now, I'll go ahead and create a model for input setup type A, which means we will be using all the variables to predict the final grade G3. I have tried various optimizers and various values for kernel regularizers and was able to achieve best model with this architecture. I have an input layer with 64 neurons, 2 hidden layers with 64 and 32 neurons each. I have added an L2 regularizer Now, I went ahead and created a model for input setup type A, which means we will be considering all the variables to predict the final grade G3. I have tried various optimizers and various values for kernel regularizers and was able to achieve best model with this architecture. I have an input layer with 64 neurons, 2 hidden layers with 64 and 32 neurons each. I have added an L2 regularizer as data was overfitting after few epochs. I have used ReLU as the activation function in the input and the hidden layers. My output layer consisted of 5 neurons as I am trying to classify grades into 5 classes, and my activation function in the output layer is softmax. Since it's a classification problem, my loss is categorical cross entropy. Adam is the best optimizer for classification as it has combined capabilities of ADA delta and RMS prop. I have compiled the model for 200 epochs and a batch size of 5 and saved the model to a H5 file. Now I went ahead and loaded the saved model and calculated the accuracy of the model. I achieved an accuracy of 78.33% for model A, which is in line with the results from the paper. They got 78% when they used decision tree classifier. Now I went ahead and predicted the values using the saved model and converted them to grade levels as mentioned in the paper. Next, I have generated a confusion matrix. For better visualization, I have plotted confusion matrix. I have used plot confusion matrix function. Let us analyze the confusion matrix results now. The diagonal elements are the ones which are predicted correctly. They are called true positives. Out of 60 samples validated, we were able to classify accurately for 47 samples and remaining 13 were classified incorrectly. These are the plots for loss and accuracy. Now I went ahead and dropped the second period grade to analyze the impact on final period grade G3. Once I dropped G2, I have created test and train datasets. Now I performed one-hot encoding of the categorical models and built a model and achieved an accuracy of 61.67%. Next, I went ahead and predicted the grade levels using the saved model. Once I predicted, I have converted them to grade levels as mentioned in the paper and then generated the confusion matrix. The diagonal elements are the ones which are predicted correctly. And out of 60 samples validated, we were able to classify accurately for 37 samples and remaining 23 were classified incorrectly. These are the plots for loss and accuracy. Next, I went ahead and created a model for input setup type C, which means we will not be considering either first period grade G1 or the second period grade G2 when predicting the value for the final period grade G3. So first I dropped G1 and G2 from the data frame. Next I splitted the dataset into train and test. Now I went ahead and performed one-hot encoding of all the categorical variables. Next, I have built a model using the same architecture I described earlier. Now, I went ahead and evaluated the model with the test dataset. I was able to achieve an accuracy of 46.67%. Next, I converted the results to grade level terms as mentioned in the paper and then generated a confusion matrix. Upon analyzing the results of the confusion matrix, we notice that we are able to classify accurately for 28 samples and remaining 32 were classified incorrectly. And these are the plots for loss and accuracy. As you can see, the validation loss is increasing and the accuracy for the model is decreasing when compared to the models A and B. I have tried various ways in order to create a best model. First, I tried standardizing the data and I achieved an accuracy of 67% compared to 78% without normalizing the data for input setup type A. Normalizing doesn't always help. I have tried to increase the hidden layers and the number of neurons, but accuracy did not change. I tried adding dropout to the first hidden layer alone, accuracy did not improve. I have tried running the model with SGD optimizer and accuracy achieved was less compared to that I achieved with Adam optimizer. I have tried applying fold cross validation with 10 splits and accuracy achieved was 64%. I have tried running the model using RMS prop with various learning rates. Accuracy achieved was around 60%. From the results, we noticed that we were able to achieve the results that are present in the paper via neural network. As you can see, the accuracy of the model is decreasing as we drop the grades G1 and G2. To conclude, I have built 3 models and achieved accuracy of 78%, 61.67%, and 46.7%. These results prove that dropping second period grade and first period grade have high impact on the final grade achieved by the student. Education is very crucial for entire society. Building such models using past grades really helps teacher concentrate on the subject students' knowledge is lacking and helps in building strong foundation skills to achieve success in the respective subjects. In this paper, we have considered only the impact of dropping first period grade G1 and second period grade G2. Our dataset consists of many features such as father's education level, mother's education level, family relationships, etc. More research should be conducted to understand how those features affect students' performance. Thank you, everyone.